A sample of the gas occupies a volume of 1.246 liters at STP. It was placed in a different vessel with a volume of 1.40 liters, in which the pressure was measured at 108.5 kilopascals. What is the temperature in this second state of the gas? Our first sentence gives us all the initial information for our gas, so this refers to the initial state. Standard temperature and pressure, and a volume of 1.246 liters. Different color pen here. I'm going to use red. This information refers to the final state, and they're asking for the temperature, so we're looking for T2. T2 equals question mark. The other thing that's different about this problem, otherwise it's exactly the same as problem number 4, is that we have a weird unit here for pressure, pascals, kilopascals in particular. Pascal, of course, is the SI unit for pressure, and what we need to know, since we're looking at standard pressure for our initial state, what is standard pressure in kilopascals? Well, we will get that from a table or some reference. 1 atmosphere is 101.325 kilopascals. So we're going to use this number for our P1. So let's start writing our variables here. P1 is going to be 101.325 kilopascals. Our initial conditions, our initial temperature, standard temperature, put that right in kelvins, 273.15 kelvins. And our initial volume was given at 1.246 liters. 1.246 liters. P2, second condition or final condition of our gas, 108.5, 108.5 kilopascals. Temperature is what we're looking for, so we'll put a question mark there. And our final volume was given at 1.410 liters. 1.410 liters. So now have everything. We need, of course, the combined gas law equation. So that's going to be P1 V1 over T1 equals P2 V2 over T2. Now, the tricky part here, the algebra might be a little difficult, so I'll step through all of the steps here. Since T2, what we're looking for is in the denominator, we're going to multiply both sides of the equation by T2. That's going to cancel T2 from the right side of the equation, and I'm now left with, let's write it out, T2 P1 V1 over T1 is equal to P2 times V2. Now, since we're looking for T2, we're going to multiply both sides of the equation by T1 over P1 V1. So let's multiply this side by T1 over P1 V1. P1 V1 cancel on this side of the equation. T1 cancels on this side of the equation. I'm now left with my desired T2 all by itself upstairs in the numerator, and now I'm going to collect terms on the right hand side. So we're now going to have our final form of the equation. T2 is going to be equal to P2 V2 T1 over P1 V1. So now we're just going to substitute numbers in. So we're going to scroll up and down here. P2 was 108.5 kilopascals. So we're going to write 108.5 kilopascals. V2, our final temperature, 1.410 liters. T1 was standard temperature, so 273.15 kelvins. And then downstairs, P1 was standard pressure, 101.325 kilopascals. And V1, that was given at 1.246 liters. So we have 1.246 liters. Our units of kilopascals cancel. Our units of liters cancel. We're left with Kelvins upstairs, which is good because that's what we're solving for. Remember, T2 is our variable. And now we're going to do the math. So we can turn on our calculator. And doing the math, we get a value of 331.0 kelvins. And that is correct. We do need 4 significant figures on that: 4, 4, 5, 4, and 6. So there's our final answer. Did they ask for it in degrees Celsius? No, they just asked for what is the final temperature. So we can leave it at that. If you do want it in degrees Celsius, of course, we're going to subtract 273.15 from that, and we're going to get a value of 57.9 degrees Celsius.